Welcome back, everyone. We're still working on free response practice 1. Here is a video of me going over question 2. As a reminder, especially if you didn't watch that first video, I'm going to kind of approach this problem from the beginning, as if I was taking it for the very first time, in the sense that I'm going to read the problem. I'm not going to assume that I've seen it before, maybe double checking things. Again, granted, I have seen this problem before, I've written out solutions before, but I think it'd still be helpful to see that, yes, you have time to carefully read the question. Maybe reread the question, go back and double check things. Okay, I'm going to show you that I kind of start with some big bullet point ideas, and then if I have time, I go back and fill in details, and then we'll also keep an eye on the clock. This is the second question. It's that paragraph length response, and you're going to have 15 minutes. So following along with me, we can check the time. All right, and I also might kind of jump in and say some tips to you about some of these problems, and you'll probably see that we're still okay for time. So you don't have a huge amount of time. Remember, I don't recommend you waste 5 minutes scouring through your notes, but you should have time to clearly read the questions, understand what it's asking, and then write down your answers. Okay, so I'm going to get my timer out. Let's see, it's not accepting my Face ID. That's embarrassing. Got my timer. I'm going to hit start, and then we're going to read problem 1. Here we go, and start. Put my phone down. This is question 2. Okay, question 2. It says, 2 identical spheres are released from a device at t equals 0 from the same height h as shown above. Okay, so I have this picture here. There's that h. Looks like I have these 2 balls, 2 spheres, sitting on some kind of ledge. It says they're released from the device at t equals 0, the same height. So they're both released at the same time, all right, and they have the same height, and they're going to, looks like, fall to the ground, fall to the floor. Sphere A has no initial velocity and falls straight down. Okay, that kind of matches this picture. Maybe I'll write down v not equals 0. It has no initial velocity and falls straight down. Sphere B is given an initial horizontal velocity of magnitude v naught. Okay, so B starts with this, v naught. So this is for A, this is for B. And travels a horizontal distance d before it reaches the ground. The spheres reach the ground at the same time, TF. Kind of weird they're giving me a label for time. Okay, I don't know, TF. Even though sphere B has more distance to cover before landing. Air resistance is negligible. Okay, I don't have to worry about air resistance. So I have these 2 spheres. They're released at the same time. They're both going to hit the ground. The problem tells me they hit the ground at the same time. V, or sphere A, just drops, but B is given some horizontal push. Okay, let's go on. Letter A. The dots below represent spheres A and B. Okay. Draw a free body diagram showing and labeling the forces, not components, exerted on each sphere at time TF over 2. TF over 2. What was TF? TF. Spheres reach the ground. Oh, TF was the time they hit the ground. Okay, the time they hit the ground. So TF over 2, it's half the time before they hit the ground. That's weird. I don't know. Would that be like halfway? Would it be more down here, more up here? Well, they're certainly in the air, right? So TF over 2, it's when they're in the air. So I'm drawing free body diagrams while they're in the air. Okay, when sphere A is falling, that's classic free fall. There's only one force acting on A, and that's weight. I could put W. Now I could also put, I'm going to chime in, you could put FW like this, you'd get full points. You could put MG, you'll get full points. I'm sure of it, okay? But it did say to label the forces, so choose one of these forces. If you wanted to put F weight to be super clear, okay, but probably not needed, okay? So for A, has weight. Now B was given a horizontal velocity, but I remember Thrasher's projectile motion. It's still an object in free fall. There's no forces, nothing is making it accelerate left or right, especially after, right? After whatever gave it that horizontal push. F/2, it's when it's in the air somewhere. So it's still just falling due to Earth's gravity. So I should just also have a weight like this. I'm going to chime in again. Sometimes they will give points based on whether these arrows are the right length. So for example, if you had a free body diagram and on a certain object, a box sitting on the floor, the normal force might need to equal the weight. They might take off points if you don't have those arrows roughly the same length. Or if they said here, if the spheres had the same mass, well, therefore they have the same weight, these arrows should be the same length, roughly, approximately. Okay, they're not going to bust out like a nanometer measuring device. All right, so if you can spare the time, maybe think, are those arrows the right length? They don't do it all the time, so having arrows is most important, but right length can also have some points assigned, so just be aware of that. Okay, I think I'm good for part A. I'll definitely double check if I have time. Okay, B, on the axes below, sketch and label a graph of the horizontal component of the velocity of sphere A and of sphere B as a function of time. Okay, the horizontal, on the axes below, sketch and label the graph of the horizontal component of the velocity of A and B as a function of time. Okay, so I'm making graphs of both A and B, so it seems like I'm going to make two lines. Let's do it for A. For A, it just falls, right? It just goes straight down. It doesn't start with horizontal velocity. It doesn't end with horizontal velocity. You're going to see Mr. Thrasher having trouble drawing a straight line on my graphics tablet. But I should have 0 velocity for A. I should make sure it's clearly labeled. Maybe I write VA, maybe I write like A like this, but it should be at 0. It never has a horizontal velocity. Okay, and this is at 0. Okay. Now, sphere B, it says it was given an initial horizontal velocity. Okay, so it starts moving horizontally. And of course, it's still projectile motion. That horizontal velocity is constant. So for B, I'm going to switch to green. For B, it should be some non-zero, right? B has some horizontal velocity. So it's not 0, it's some value. It just says sketch. Sketch means make a rough sketch. You're not plotting numbers. So make a rough sketch. Maybe I'll choose right here. It doesn't really matter. It should have some constant, not changing horizontal velocity. Or maybe I put B like this, one of those two. Okay, yeah, that makes sense to me. Let's check the time. Remember, I have 15 minutes. I'm at 6 minutes and 30 seconds. So I still have over half my time left. You know, I'm starting at 0. Should I start like down here and include like the flick of the sphere? I mean, they don't really include that. It says it's given some initial horizontal velocity. Yeah, like they're not making any reference of include the time before the ball was moving. So I don't think I have to do anything like start B down here and make it like jump up or something. Maybe they take a point off, or maybe they'd accept it. I don't know. But this is certainly the general sketch of the graph. It has a constant velocity. I should be getting some points for showing that the ball B has some constant horizontal velocity. Okay, maybe I'll think about it if I have more time later. C, in a clear, coherent, oh God, here we go. Here we go. Thrasher's been training me for this all year. In a clear, coherent, paragraph-length response, explain why the spheres reach the ground in the same time, even though they travel different distances. Include references to your answers in part A and B. In a clear, coherent paragraph, they don't say I can't use an equation. Okay. Explain why the spheres reach the ground at the same time. So why is that true? Why are they reaching the ground at the same time, even though they travel different distances? Include references to your answers in parts A and B. Okay, oh God. So maybe try and include these things? Well, I mean, I feel like I've seen this problem before. Mr. Thrasher always said the time for a projectile, the time something is in the air, it's based on that vertical stuff. It's based on how it's moving vertically. Both these spheres have a whole lot of things in common. Both spheres fall the same vertical distance and feel the same constant acceleration from gravity. Now, to be honest, maybe I should go back and say like they feel the same force and therefore the same acceleration, because it does say to use stuff in A and B, and in A I'm making free body diagrams. If I have time, maybe I'll go back and fill that in. Okay, but if this is just a projectile problem, well, I mean, this is true. Okay, they fall the same vertical distance and they have the same constant acceleration. Let's see, what else? Both start with 0 vertical, vertical velocity. Both start with 0 vertical velocity. Okay, so they have the same height, the same h. They have the same acceleration. They both have v naught y is equal to 0. Is that enough? Can I think of an equation? Like there's this equation, right? I have delta y equals v naught yt plus 1/2 gt squared. So v naught y, this is 0 for both of them. So I have delta y, that's h in the problem. H is equal to, this is 0, because v naught y is 0 for both. So this is for both. So h is equal to 1/2 gt squared. Okay. I don't want to just do all math, because they do want a paragraph length response. Okay, so maybe, let's see, can I add another slide? Okay, so let's see. So from that equation, if both fall the same height with the same acceleration, the time to hit the ground is the same for both. Okay, yeah, I feel like we've done those similar. Okay, I didn't want to do too much math because it is asking for a paragraph. Let's check the time. I am at, just about 12 minutes. So again, I got about 3 minutes. And again, I read all the questions. I might add in some detail. Maybe I'll jump in here and I'll say, from the free body diagram, the forces are the same on both. Therefore, they have the same acceleration. To be honest, I never talked about horizontal velocity in my paragraph, and here's a test tip, or here's something to know about this problem. I know in the free response, they assigned a point for indicating, quote unquote, for indicating that horizontal and vertical vectors don't affect one another. And notice, I didn't say that. And when I first approached this problem, I didn't directly write a sentence saying the horizontal vectors and the vertical vectors don't affect each other. So it's possible maybe Mr. Thrasher wouldn't have gotten that point. But to be honest, it's also possible that they might say, well, he did kind of indicate that they don't affect one another, because nowhere in my explanation did I talk about those two things. Maybe, it kind of, some of the points come down to what is the grader gonna think, all right? It did say in the problem, though, to include references to A and B and explain why they reach the ground at the same time, even though they travel different distances. So since they're pointing this out, it might be, again, if you have time, it might be worthwhile to be like, oh, okay, they're really referring to this. So maybe I'd add another sentence. Even though they are traveling different horizontal distances, that didn't affect the time to fall downward. You know, just trying to increase the chances of you getting those points. Okay, and again, maybe I would double check that graph, but again, if it says sketch, well, they just expect a rough, sketch. And also, to be honest, I don't know this year the odds of a graph question or admittedly a free body diagram question, right? Because how do they expect some people on iPads or on their laptop to sketch a graph? I don't know if they have that kind of interface. Maybe they might have a multiple choice which of these graphs is best, but that's pretty different from their normal question. So to be honest, it might be less likely that you'll have a free body diagram question or a graph question, but hopefully this physics still makes sense. And I'll point out that while I've been giving these tips, I still haven't reached the 15 minutes. So again, you have time. You have time to read the question, process the question, write down your answers, and then potentially go back. I would not just, if you have 3 minutes, don't just be like, I'm done. Right? This isn't a super long test. It's like a little over an hour total, a little less than an hour. So if you have 3 or 4 minutes, go back, reread questions, add some stuff in. Okay? But that's this video. Thanks a lot for watching. As always, you could email me questions. Take it easy.